Hello and a very warm welcome to the second lesson on time, speed and distance. Like the previous video tutorial, this lesson is also about dealing with questions based on variation. That is, a change in one factor bringing about an inverse or direct change in the other factor, keeping the third factor of time, speed and distance constant. Now let us begin with the first question. This problem states that Myra and Jack leave simultaneously from point A and point B respectively towards each other, and they meet at a point 100 kilometers from A. If the distance between 2 points is 250 kilometers, what is the ratio of Myra and Jack's speed? Now the total distance is 250 kilometers and time is constant here. If Myra and Jack meet at a point 100 kilometers from A, that means Myra has covered a distance of 100 kilometers in some time and Jack has covered a distance of 150 kilometers in the same time. This means that distance of Myra over distance covered by Jack is equal to 100 over 150, which is equal to 2 over 3. Since speed and distance are directly proportional, therefore speed of Myra over speed of Jack is equal to 2 over 3, that is 2:3. This question says that Joshua meets with an accident and moves at 3/4 of her original speed. Due to this, she is 20 minutes late. Find the original time for the journey. Now, our first step should be to see what is constant here. And according to this problem, we can see that distance is constant here, but speed and time are changing. Our second step should be to see the relationship between speed and time, which is inverse. Therefore, a change in speed will bring about an inverse change in time. So if speed is 3/4 of the actual speed, then the time t taken to cover distance d will be 4/3 of t. We know that Joshua is 20 minutes late after she travels with 3/4 of the original speed. Therefore, 4/3t minus t is equal to 20 minutes, right? And if we simplify it, we get the original time for the journey to be 60 minutes or 1 hour. Now, if we were asked to calculate the time taken by Joshua to travel with 3/4 of the speed, then we would have added 20 minutes more to the original time. That is 60 plus 20. And our answer would have been 18 minutes or 1 hour and 20 minutes. You got it? Let's move on to the next question. If Sally walks at 14 kilometers per hour instead of 10 kilometers per hour, he would walk 20 kilometers more. What is the actual distance traveled by him? Now, our first step should be to identify the constant, and in this problem, it is time, while speed and distance are changing. So if our original speed is 10 kilometers per hour and our new speed is 14 kilometers per hour, that means 10 is multiplied by 14 over 10 to get 14. Now kindly understand this crucial point. We are simply multiplying and dividing the new speed by the old speed. And the reason is because the fraction multiplied by speed to get new speed is going to be multiplied by distance d, because speed and distance are directly proportional. So the actual distance is d and the new distance is 14 over 10 of d. Now we know that 14 over 10d minus d is equal to 20 kilometers. Therefore, d is equal to 50 kilometers, which is the actual distance traveled by Sally with a speed of 10 kilometers per hour. The ratio between the speeds of A and B while covering a distance is 7:8. If A takes 20 minutes more than B, calculate the time taken by B to cover the distance. Now, distance is constant here and the ratio of speed of A and B is 7 to 8. We know that speed is inversely proportional to time. Therefore, ratio of time of A and B will be 8/7 or 8 to 7. Now you see, we can interpret that A takes 8x minutes to cover a distance and B takes 7x minutes to cover the same distance. And the difference between the time of A and B is 20 minutes. So 8x minus 7x is equal to 20. That is, x is equal to 20. Now that we know the value of x, we can easily calculate the time taken by B to cover the distance. Time taken by B is 7x and x is 20. So 7 into 20 gives us 140 minutes or 2 hours and 20 minutes. Alize travels with 5/7 of her actual speed and covers 35 kilometers in 1 hour and 20 minutes. Calculate the actual speed of Alize. Now you see distance is constant here and Alize's new speed is 5/7 of her actual speed. Time, as we know, is inversely proportional to speed. Therefore, time will be equal to 7/5 of the actual time, right? So, with 5/7 of Alize's speed, time will be 7/5 of the actual time, which is 1/3 hours. That is 1 hour and 20 minutes, right? Now, this can further be simplified to get 4/3 hours. So, 7/5t is equal to 4/3 hours. And transposing 7/5 to the other side, we will get t equal to 20/21. Now we know that time into speed is equal to distance. Time here is 20/21 hours and distance is 35 kilometers. So 20/21 into speed is equal to 35. Simplifying it, we get the actual speed equal to 36.75 kilometers per hour. Right? This concludes our second lesson on time, speed and distance. I hope you are understanding step-by-step method of solving questions based on variation. I will be uploading the third lesson on the same topic in a few days. So please stay tuned to this channel. Goodbye for now and thank you very much.